Now here's the second technique that I'm going to teach you. And to do this technique, I'm going to have you do the question that deals with a square being lengthened and then ending up with a different square inch total. So give that question a try, and then we'll go through. Okay, now one nice thing about the SAT that you probably haven't thought about is that the SAT people give you the correct answer on virtually every math question. The trouble is that they also give you 4 incorrect answers. So basically with a question like this, if we look at the last line, it says, what is the length in inches of a side of the original square? And our answer choices are 4, 6, 8, 9, and 10. I haven't worked through this question yet, but I'll tell you one thing. I guarantee you that the correct answer is either 4, 6, 8, 9, or 10. There are no other possibilities because those are the answer choices that they've given us. Another thing that happens on the SAT is that when they are giving you the answers, they always order them from the smallest to the largest or from the largest to the smallest. And answer choice C is the one that's in the middle. Okay, so our technique is back solving, and here's what we're going to do. We're going to read the sentence or the question paying attention to the last line. Okay, the last line in these questions is basically saying, what's the correct answer? So on ours, we need to find what is the length in inches of a side of the original square. We're going to start with answer choice C because answer choice C is the middle, and we're going to check it to see if it's right. So if our original square were 8 by 8, that would be 64 square inches. And if we increase this square by 3 inches, our square will now be 11 by 11, which means that that is 121 square inches. Now what we know is that when we increase our size on our square inches increases by 63, okay? In this case we have 121 and 64. 121 minus 64 is going to give us 57. But what we're looking for is 63 inches difference. Okay, so when our square is just 8 by 8 and we increase it by 3, it only increases the square footage by like 57. It's not enough. So what we know now is that answer choice A, answer choice B, and answer choice C are all wrong. There are only 2 possibilities. Let's take a look at D. D would have our original square be 9 by 9, which would be 81 square inches. And then if we increase each side by 3, we would be at 12 by 12. And if our square is 12 by 12, that's 144 square inches. So let's figure it out. 144 minus 81, hot damn, it's 63, which is exactly what we're looking for. So here's the deal. If you're tempted to set up an equation to solve an algebraic equation like this, don't. What you're going to do is you're going to go through the answer choices, start with C, plug it back into the question, and check to see if it's correct. If it is correct, that's great. If it's not, you're either going to go bigger or smaller until you find the answers that is correct. One thing you've probably found is when you take a standardized test and you come up with an answer, when you look down at the answer choices, that answer is always one of the ones that they give you. Here's what happens. The people who write these tests can anticipate how you're going to screw up. They're going to say, oh, little Jimmy's going to forget to carry the 1. Or, you know, they're going to come up with all these answer choices that you could get if you screw it up. The nice thing about back solving is that when you come up with an answer choice, you know damn well that that is the correct answer choice because you've already checked it. Okay, so this is a very powerful technique. What you want to look for are questions which have a finishing sentence which says, in effect, what's the correct answer? And the answer choices will always look pretty much the same. They'll be integers going from largest to smallest or smallest to largest. And these are questions that you can back solve on. Let's try another question and I'll walk you through it. So questions that you can back solve on always have integers as their answer choices. They always have a final line which is saying, in effect, what is the correct answer? Okay, let's try this question with Amy. We know that Amy is now twice as old as Bill, and that 10 years ago, she was 4 times as old as Bill was then. Now the money line. How old is Bill now? Okay? So, with back solving questions, a lot of times what will help you out is to come up with a little chart so you can keep your elements in order. In this question, we have Amy and we have Bill, conveniently A and B. So, we have A and we have B and we have a little chart. And our last line is saying, how old is Bill now? We're going to go to answer choice C and try that out. Okay, answer choice C says that Bill is 15 years old. Now we can go back to the beginning of the question. It says Amy is now twice as old as Bill. So if Bill is 15, how old is Amy? She's 30. So let's put it into our chart. If we read on, it says 10 years ago. Okay, so 10 years ago. If Amy is 30 right now, how old was she 10 years ago? She was 20. And how old was Bill? Bill was 5. Okay? So now we're going to see if it's a correct answer. It says 10 years ago she was 4 times as old as Bill was then. Well, if she's 20 and Bill is 5, that's 4 times as big. That's the correct answer. A little added bonus with questions like this is that statistically, answer choice C is correct more often than any of the other answer choices on a back solving question. So more often than not, you might only have to plug in one or two answer choices to get the correct answer.